Now in this training we will concentrate on NFS version 3, but as with any software there are multiple versions available, and with NFS we have version 4.0 and 4.1 which have some beneficial things that we have to address very quickly. Version 4.0 offers referrals. When a client mounts a volume which is not local to the IP address that it accesses, the client will be redirected to remount the volume via an IP address which is local to the volume. This is only a one-time action, so that means when you mount it, it will be mounted via the correct IP address which is local to the volume. NFS version 4.1 offers parallel NFS, which means that the mount through an IP address will still be valid even if the IP address is not local to the volume, but the data path that the client will use will be a path via an IP address which is connected to the node that also hosts the volume. This has an additional advantage because if the volume gets moved, then the data path will move along, which is very nice. Interesting to note is that version 3 uses multiple daemons and multiple ports, whereas version 4 only uses one port and one single protocol. Also 4 supports ACLs. There's a lot more to read on that. You should have a look at the technical reports if you want to have a better overview of NFS version 4.0 and 4.1. Yet, the bulk of actions that you have to take to successfully mount NFS volumes, whether you use version 3 or 4, it doesn't really matter. The policies and all that stuff are basically the same. Now let's have a look at export policies for NFS. What you see here is we have a storage virtual machine which is called DNFS, and we have a default policy which is empty. With every volume that you create, there will be a volume property which is called policy, and this is the export policy which is the default, and it's empty. You can add rules to that, so like the lines in a configuration file, you can add rules to the policy. Or you can create a new policy and connect that policy to the volume and fill the policy with particular rules. So again, the default policy is empty and it cannot be removed either. So when you want to add rules to the policy, it is important to realize that the rules are read in a sequential manner. That means if you open up your volume to the entire subnet or to the entire world even, then adding subsequent rules for specific IP addresses would not be very useful because every IP address, so every client matches the first rule. So the rest of the rules will be ignored. If you create a policy, it's obvious that you use a command which is called export policy create. Adding rules to that policy would be possible with export policy rule create and then specify the policy in which you want to create the rules. So when you create a policy, there are 3 items you have to supply at least. And the first one is client match, meaning any of the clients that match this particular entry, so be it a subnet or a domain name or a specific IP address, then the following 2 rules will be applied. The first one is the read-only rule, and the second one is read-write rule. Obviously meaning you're allowed to read and you're allowed to write. Now the thing is that the read-only rule and read-write rule require a particular security type. So for example, and this can be a comma-separated list as well. For example, we're going to check or authenticate a user against any of the following security types. For example, sys, which is authsys or Kerberos or NTLM. Or if you want to take an easy ride, you simply say, I'm going to allow any of the security types that match. None means that if none of the other security types match, then we're going to map this user to an anonymous user for reading or for writing. And never simply blocks access. Now to summarize this, let's have a look at a paper example. What we see here is we have a root policy, and the policy is called rootpol, and the client match, or the one and only rule inside this policy is we are going to match any client in any network, and the read-only rule is any, meaning that We don't care about authentication types. So everybody is allowed to read, and nobody is allowed to write. So this policy is connected to the root volume, which is vital, because if you do not connect a policy to the root volume, that means that your root volume will not be accessible by any client, no matter what. So you will not be able to access your volumes. So it's very important, your root volume, which is the starting point of the namespace, will need an export policy, and that export policy will need a minimum of one rule to open up that particular path to any of the volumes. Then we have a data policy, and this data policy is connected to two volumes, and these two data volumes will have a client match of one particular IP address, and that client is allowed to read and is allowed to write, and it also has superuser access. This means that if, for example, VMware, who wants to write as a superuser, as root, its VMDKs and its virtual machines to your data store, then it will try to do that as root. And if superuser is not opened up for VMware, then VMware will not be treated as root, which means that it will not be allowed to write. So in some cases, you have to open up your volume for superuser access. The second rule we find in here is the client of any network in the world is allowed to read and will be mapped to anonymous if it tries to write. And superuser also is blocked. So the export policy, as we see here, is connected to a volume. The policy contains rules. The rules determine which clients are allowed to access and with which permissions. And the rules are applied in sequential order, which is relevant. And root volume should also be exported. And authentication methods that we have are the ones that are listed here.